So this is proximity profile. For implementing the proximity profile, I'm going to use the proximity tag example program at BLE stack 2.2.1 as reference. So the BLE stack 2.2.1 is here, and you can find the proximity tag example source files here, source examples. So proximity tag, proximity tag here. So okay. So what I'm going to do is port the proximity tag codes to simple key finder. So just example of the codes I'm going to port is here for this code for link loss alert. I'm going to port to simple key finder link gap roll waiting after timeout. So I'm going to port this one from proximity tag.c to simple key finder.c here. So after porting, I'm going to do a code review to show how alert from link loss and immediate alert happens. So at the BLE Stack 2.2.1, there's another Bluetooth tracker example program called the key fob. So the key fob code is same with proximity tag but with added support for BMA 250 accelerometer. Okay, so I'm going to do the part. Okay, so I have already done the code porting. So just example of the ported codes here at proximity tag.c for the link loss alert to simple key finder.c. Okay, so I also added the proximity profile files. So which is located at source ti stack profiles proximity. So I drag and drop the reporter.h and prox reporter.c at profiles folder. So the proximity profile is based from this document. So the PXP version 1.0.1. So so the code implementation for the proximity profile is based from this document. So just reading the abstract, the proximity profile enables proximity monitoring between two devices. So this proximity profile has been adopted by Bluetooth SIG. Okay, introduction. The proximity profile defines the behavior when a device moves away from a peer device so that the connection is dropped or a path loss increase above a preset level causing a immediate alert. So a link is provided for you to download this document. Okay, so this is code review. So from proximity tag.c, I only ported the codes necessary to support the proximity profile. So for link loss alert and immediate alert, here are the levels of alert. So alert state off, alert state low, and alert state high. For alert state low, the buzzer will sound at a frequency of 2400 Hz. For alert state high, the buzzer will sound at a frequency of 4000 Hz. So The buzzer will sound at the maximum beeps of 5. So you can change this. First, I'm going to discuss about immediate alert. So for immediate alert, when you write uh, alert state low to immediate alert characteristics, for example, it will go to this callback. So this is the proximity peripheral profile callback. So it will go to the simple key finder proximity attribute callback. It will queue with QID SPP prox card change event and pass the immediate alert profile attribute value. So which is 1. So once you queue, it will go to main task here to process that event. So since this is a valid event, the device will transition from standby mode to running mode to process that event. So since this is a queue, it will go to here and go to simple key finder process up message. So we use it will process the QID SPP prox card change event and go to here simple key finder process proximity attribute event. So for immediate alert, it will go to here. Okay, and then it will determine the level of alert. So we pass 0x01 for low level alert, and then it will perform the alert. So it will go to here. Since we set 0x01 for low level alert, it will start the buzzer play and set the low frequency, which is 2400 Hz. For buzzer tone, the duty cycle is always set to 50, and it will start the clock, which will turn on the buzzer at a regular interval for 200 milliseconds, so 5 times. So here. Okay, so this is code review for link loss alert. So, I will first discuss about the gap role states. So when the simple key finder first initializes, it will go to gap role started, and then it will go to gap role advertising and advertise. When there's Bluetooth connection, it will go to gap role connected. When you intentionally terminate a link, for example, you turn off the Bluetooth at the smartphone app side, it will go to gap role waiting. When the link is terminated or dropped due to supervision timeout, for example, this is caused by, for example, you walk away from the Bluetooth tracker, the link will be dropped. So that is link loss. So when link loss happens, it will first turn off the immediate alert and then go here to perform the link loss alert. Go to simple key finder perform alert. So it will go to here. For example, we set a alert level high for link loss alert. It will go to here and set the buzzer play with frequency of 4000 Hertz. Okay, and set the duty cycle to 50, and then we'll play the buzzer at a regular interval of 200 milliseconds 5 times. Okay, so this is PWM buzzer code review. So the PWM is initialized with default parameters. So the PWM output is set to default for red LED. So you can change this to whatever IOs are available at the launchpad. For buzzer play, we set the frequency and duty cycle. So this code is from the PWM oxygen documentation. So here, so setting of PWM duty and period. We use PWM set duty and period C function. So here, for stopping the PWM, we call PWM stop. So this buzzer play you can use to uh, play tunes, for example, Mario Brothers, Happy Birthday, Konami. Okay, but for this project, we're just going to use the buzzer play for low level alert and high alert with frequency 2400 Hz and 4000 Hz. So I will rebuild all this simple key finder and flash the hex file to CC2640 RTF Launchpad. Okay, so I already flashed the hex file. So this is the setup. So I removed the jumpers at P4 and P10, and this is powered by a coin cell battery CR2032. So the buzzer circuit is resistor in buzzer. So the value of the resistor is 220 ohm. The resistor can range from 100 ohm to 1K. So this resistor and buzzer circuitry is just based for it's just for project purposes. For product level, this is not the circuit that is used. So the PWM output is connected to red LED DIO6. Then I connect the ground. So okay, simple key finder. Okay, so first we detect the key press. Okay, so I press the left button and then the right button. So this key press detection you can use to locate your smartphone. Then for link loss we can set okay, I will test the immediate alert. So right 01 so right so right 02 So for link loss, I'm not able to test at the moment. So I need to but I tested this link loss by putting the smartphone inside the refrigerator. Okay, so now you have a basic hardware for Bluetooth tracker.